This presentation aims to provide a detailed analysis on the various programming languages that can be used to develop computer viruses. To start off, it is worthwhile to know what a computer virus is. A virus, by definition, is a computer program that can replicate and infect a PC without the knowledge of the user. How does a virus affect a PC? Well, a virus can erase valuable data. It can cause the machine to function erroneously. It can also cause hardware connected to the system to function hazardously. Now, let's look at the functional elements of a virus. There are three main functional elements of a virus. Firstly, a virus should contain a search routine which locates new files or new areas on disk which are worthwhile targets for infection. Secondly, a routine to copy itself into the area which the search routine locates. And thirdly, anti-detection routines, which are additional features that can be incorporated into a virus to avoid detection. Now, let's look at the overview of viruses over time. Well, the first computer virus, popularly known as the brain virus, was created in 1986. This virus was spread via floppy disks and infected the boot records and not hard disk drives like most viruses do today. The first PC-based Trojan horse was distributed the same year, disguised as a then popular shareware program, namely PC Write. The Michelangelo virus, which is one of the first viruses to spread over the World Wide Web, was one of the biggest strikes in the early 1990s. In 1996, the first virus which was designed to penetrate the Linux operating system was developed.
And now let's look at a few types of computer viruses. We have the resident viruses which dwell permanently in the RAM and can basically interrupt all the operations executed by the system. And then we have the direct action viruses which replicate and take action whenever it is executed. And we have overwrite viruses which delete information contained in the file that it infects, rendering them partially or totally useless. And we also have boot viruses which do exactly what its name suggests. It affects the boot sector of floppy or hard, causing problems with boot up. And then we have macro viruses which infect files that are created using certain applications or programs that contain macros. And we also have directory viruses which change the paths that indicate the location of a file upon indication. And then we also have the polymorphic viruses which morph themselves each time they infect a system. We also have the file infectors, which are the most common type of viruses, and they infect programs or executable files. We also have the companion viruses, which can be considered as file infector viruses which act as resident or direct action types. And we have the fat virus, which is one of the most dangerous types, as it can restrict access to certain sections of the disk where important files can be stored.
Now, let's look at the evolution of computer viruses over time. The earliest viruses were distributed via floppy disks, whereas modern viruses are distributed via the internet. To facilitate this, most modern viruses are equipped with features such as stealth, which hide the presence of the virus in a computer system. These are some of the modern day viruses: macroviruses, mass emailers, and viruses which use polymorphism as a technique, and viruses which use blended attacks and techniques such as armoring to protect themselves from the computer system. The recent trends of computer viruses can broadly be classified as the development of dynamic software updates, new infection vectors, and data stealing payloads.
Now to take a look at a few programming languages that are used to develop viruses. Viruses can be coded using any programming language. We already know that a virus is a small program coded to cause some form of destruction to a computer and cause inconvenience to its users. We will be focusing on the programming languages stated here and its use in developing computer viruses in developing computer viruses. During the rest of the presentation, we will see a few brief introductions to each type of language that we will be focusing on: assembly language, scripting languages, Java, and Windows PowerShell. Computer programming languages are of two major types: low-level languages and high-level languages. There are two types of low-level languages: machine code and assembly code. Machine codes are a set of instructions that are executed directly from the CPU. This is farthest from user-friendliness. Assembly language is the next nearest language to hardware. It is said that assembly language is the lowest level language used to program viruses. Assembly language was founded in the 1950s. It was then used to code operating systems, simple spreadsheet applications, etc. The use of assembly language has not deteriorated. It is used mainly for software that directly control hardware and for embedded systems. These are primarily software that use much less or no data sets, and they are smaller applications, usually applications that perform a single or a very minimal number of functionalities. To take a brief look at the functionality of assembly language, we can see that one line of assembly code corresponds to a line, or in some cases lines, of machine code. This illustrates the propinquity of assembly languages to hardware. One may wonder how hardware understands what it ought to perform directly from assembly code. There is an assembler that converts assembly code to machine code. Machine code directly functions with the machinery, thereby the hardware performs what it is required to perform. A key feature of assembly language is a symbolic representation of numeric machine code. This provides feasibility and user-friendliness to the programmer. Another key feature of assembly language is that it is very powerful. This is because it is very close to the hardware and therefore can directly manipulate the hardware well and accurately by giving it direct instructions. What we saw above was a very abstract overview of the functionality and features of assembly language. Based on that, many persons have expressed their opinions on the usage of assembly language to program viruses. The power of assembly language makes viruses coded using it very powerful. We learned that a key feature of assembly language is its power. A virus coded in assembly language will make that viral program as powerful as just about any program that is coded using assembly language. It can be used to directly manipulate the hardware of a computer and cause destruction. Thus, assembly code can be considered as one of the most dangerous languages used to code viruses.